Hello and welcome to today's lesson on parallel lines cut by a transversal and sum of angles in a triangle. So just quickly our objectives. Today students will use given geometric theorems and properties of rigid motion, lines, angles, triangles, and parallelograms to solve routine problems. Also, they'll use geometric theorems and properties of rigid motions, lines, angles, triangles, and parallels to prove statements about angle measurements, triangles, distance, line properties, and congruence. Okay? So let's do a quick warm-up. So I want you to know lines L and M, which in this case, it's going to be line L. Ooh, let's try a better color for that. So line L and line M, which are the same in both these, all of these, are parallel. I've given you in each one, I've given you an angle. So this first one, I gave you that angle of 40. And I'm asking you to find this other missing angle. Like I said, in each one, I've given you an angle, and I'm asking you to find the missing angle that's labeled as X. So go ahead and pause the video and try to do these. And then come back when you're done. Okay, hopefully you paused the video and did that. Let's go on and look at the answers. So you can see the answers here. If you have any questions about how to get these answers, please ask me in class. So let's look at a real quick concept summary. When we're talking about parallel lines and angle pairs, there are 4 special angle relationships, okay? So when my lines are parallel, I know, first of all, same side interior angles. These same side interior angles, notice they're on the same side and inside my lines, have to add to 180. I also know alternate interior. So again, we're still on the inside, but now look, we're on alternate sides of my transversal. Those are always going to be equal. I also know corresponding angle theorem. That tells me these corresponding angles are always going to be equal. And finally, I got alternate exterior. So again, exterior is outside of my parallel lines. Those alternate on opposite sides are going to, again, be congruent. Okay? So we're going to use these as we go on. So, in addition to knowing that those, if I know I have parallel lines, I can use those, there are criteria for proving that lines are parallel. So, let's look at the first criteria. If corresponding angles are congruent. So if the corresponding angles, like say like here and here are congruent, then I know the lines are parallel. Okay? If alternate interior angles are congruent. So, oops, let's do this in blue. Alternate interior angles, so if I know I have this one and this one, then they're congruent. If alternate exterior angles are congruent, so if I talk about like this angle here and this angle here, then they're congruent. And finally, if same side interior angles are supplementary, remember supplementary means they add to 180, then they're congruent. So I'm talking about same side interior, so that might be this angle and this angle up here. Same side interior, okay? So now let's talk about angle measures in a triangle. So there are 2 theorems here. First, we have the interior angle. So interior are the angles inside of my triangle. The sum, remember that's when we add them, of the measures of all of the angles in the triangle is 180 degrees. So angle A plus angle B plus angle C will always equal 180 degrees. That is called the interior angle theorem. Next, we have the exterior angle measure. So this says that the measure of each exterior angle, now I'm not talking about exterior angle, I'm talking about like this angle right here. See how it is? I'll do that. Sorry, I'm talking about this angle right here. It is on the outside of my triangle, and it is a continuation of this line. Okay? So that exterior angle of a triangle is the same thing as the sum of the 2 interior angles. The 2 remote. Remote just means away from. Like you use your remote control to change channels on your TV when you're away from it. So the 2 remote. So we're not talking about this angle down here. We're talking about this angle and this angle being my remote interior. So measure of angle 1 is the same thing as measure of angle 2 plus the measure of angle 3. So why are we doing this together? So what happens when I have triangles and parallel lines? If I have a triangle, so you see here, I've got my lovely triangle here. Got my lovely triangle here. And I also have a set of parallel lines that the triangle is in between. I can solve this. I can tell these are parallel because they've got these little arrows that tell me that they're going the same way. Okay? I can solve each of these. So let's start. I'm going to solve C first, just because I think, to me, that's the one that's the easiest. I can solve C because I know 123, that one that they've got labeled here, plus C degrees has to equal 180. Right? So I know that has to equal 180. Okay, well, if they have to equal 180, that means that C must be 57. It must be 57 degrees. Okay, so I know this is 57 degrees. Okay, so now let's look at another one. I also know that this line right here acts as a transversal between my two parallel lines. So this angle right here and this angle right here are alternate interior angles, which means that they are the same. So that means that 55 plus D must equal 123. That means that D must be 68 degrees. So this is 68 degrees. Now I also know that all three of these angles here must equal to 180 degrees because it's a straight line. So that I know that this one must be 57 degrees. And all that leaves me with is A. And for A, I just know that A plus 57 degrees, my angle C, plus 68 degrees, my angle D, must equal 180 degrees. Because that's the interior angles of a triangle. Okay, so I can solve for A very quickly. So I end up with A equaling 55 degrees. Okay, so I use what I do about triangles and parallel lines together in order to solve this. This is what you're going to need to do as you work on your assignments. I will see you all in class. Let me know if you have any questions.